Okay, for this video we're going to be looking at solving equations, only this time we're going to be using multiplication and division instead of addition and subtraction. So, some things to remember from our last video. Equations still have to be balanced. So what that means is if I'm doing something on one side of the equal sign, I have to do it on the other side. So if I'm adding over here, I have to add over there. If I'm subtracting, I have to subtract. If I'm multiplying, I have to multiply. If I'm dividing, I have to divide. Anything we do on one has to be done on the other side to keep it balanced. Just like yesterday, if we're asked to solve an equation, we need to make sure we're trying to get the variable by itself. We want to isolate the variable, get it alone. So again, when we're asked to solve, we're getting that variable by itself. And we're going to do that using inverse operations. Okay, so we're using our inverse or opposite operations. Now, to remember from yesterday, if we have addition, its inverse is going to be subtraction. If we have subtraction, its inverse is going to be addition. If we have multiplication today in our equation, we're going to need to use the opposite of that, which is division. And likewise, if we see division today, we need to do the opposite of that, which is multiplication. So let's look at today's first example, example 1. Okay, we can see our equation. We have 4x equals 8. The first thing I want to do is looking at my equation, I'm finding my equal sign, and I'm knowing that that equal sign is splitting my equation into two parts. I have the part on the left, I have the part on the right. Okay, I need to remember that anything I do on one side, I need to do on the other. So I'm looking at my equation right now, and I'm saying, okay, there's my x, and I'm thinking to myself, my x is on the left-hand side. What is with the x? Well, I can see that with the x is a 4 with nothing in between the 4 and the x. And because we've talked about this, we should know that if there's nothing written there, we know that really that there's multiplication. So it's telling us 4 times x. Which means if I know it's 4 times x, in order to get x alone, I can use an inverse operation or opposite to undo that times 4. So the opposite of multiplication is division. So I'm going to put a little line underneath to signify division. Because we know it looks like a fraction bar is just division. If I do it to the left side, I also have to do it to the right side. Divide. Now, what am I dividing by? Well, if it's times 4, I need to get rid of that 4, so I'm going to divide by 4. And if I divide by 4 on the left side, I have to divide by 4 on the right side to keep it balanced. Now, looking at this, if we have 4 divided by 4, that equals 1, or just whatever we have here, which is x, so they cancel out. We're left with just x equals, and on the right-hand side, we have 8 divided by 4. 8 divided by 4 is 2. So we have x is equal to 2. Again, just like yesterday, we can go through and we can check this. So we should. We know with our check, our original equation was 4 times x equals 8. If we subbed in x is 2, 4 times 2 equals 8. Now we're actually going to work out the left side to make sure this is a true statement. 4 times 2 is 8. Does 8 equals 8? Yes, it's true. So I know that x does equal 2. Let's look at our next example. 35 equals 7y. Again, what I want to do is I'm finding my equal sign. I know that that's splitting my problem into two parts, the left side and the right side. Now I'm looking at my variable. I can see it's on the right-hand side, my y, and I'm thinking, what operation is it telling me with that variable? Well, it's telling me multiplication. So if it's telling me multiplication, I need to do the opposite of that, which is divide. And if I do it on the right, I'm going to have to do it on the left. And what am I going to divide by? Well, if it's times 7 with my y, I need to get rid of that 7, so I'm going to divide by 7. And if I do it on the right, I got to do it on the left. Now looking at this, if I have 7 divided by 7, that equals 1, or just 1y, or y. So I'm going to cancel those out. I'm left with y equals. And now I have 35 divided by 7, which is 5. And again, I should go through and I should check here. Make sure I'm doing this right. 35 equals 7 times y. We're substituting in y is 5. So now I'm going to solve the right-hand side. 7 times 5 is 35. Does 35 equal 35? Yes, it does. So there's my answer. 5 equals y. Let's look at another example. I have b divided by 2 equals 12. b divided by 2 equals 12. First thing I'm going to do is I'm going to split my problem. There's my equal sign. I know I have the left side and the right side. Okay, I found my variable. It's on the left-hand side, a b. So if it's b divided by 2, I knew the opposite of division, which in this case is going to be multiplying. So if I multiply on the left, I'm multiplying on the right. And right now, if I'm dividing by 2, I knew the opposite of that, which is multiply by 2. Multiply by 2. Now as I go through, my divided by 2 and multiply by 2 end up canceling out. So I'm left with b equals. And on the right-hand side, I have 12 times 2. Well, 12 times 2 as I go through. 2 times 2 is 4. 1 times 2 is 2. 24. Now again, I can go back through and I can check this out, make sure it all works out. My original equation is b divided by 2 equals 12. I'm going to substitute my b in as 24. 24 divided by 2 equals 12. Now I'm going to solve to make sure it's a true statement. 24 divided by 2 is 12. Does 12 equal 12? Yes. So there's the correct answer. Let's look at one more example. Number 4 is n over 4 equals 3. N over 4 equals 3. The first thing I'm going to do is split my problem. Okay. Now looking at this, I can see it looks like a fraction, n over 4. But if I really think about this, this fraction bar doesn't really mean a fraction. A fraction bar means division. So really this isn't saying n over 4 like a fraction. This is saying n divided by 4. And so if this is saying n divided by 4, I know my opposite of division is multiplication. So I'm going to actually multiply on both sides. And what am I going to multiply by? Well, if 4 is being divided by, on that side I need to multiply by the 4. Multiply by 4. So now when I go through, times 4 divided by 4 end up canceling out. I'm left with n on the left-hand side. On the right-hand side, I have 3 times 4, so 3 times 4 is 12. So right now I'm thinking n is equal to 12. Well, let's go through and let's check that. So when I go through and check that, my original equation is n over 4 is equal to 3. I'm going to plug in what I think n is. I think n is 12. So I have 12 over 4 is equal to 3. Well, 12 over 4, I can go through and do that math. 12 divided by 4 is just 3. Does 3 equal 3? Yes, it does. So there's my answer. Again, we need to keep in mind when we're dealing with equations, we should have one specific thing that variable is equal to. When it's asking to solve the equation, we need to find out what that variable is equal to, and there's only one correct answer with an equation.